All right, let's dive in. Today, we are popping the hood on the technology that's completely reshaping our world, large language models. We're going to get past all that it's magic talk and actually put together an engineering blueprint for how these incredible tools are really built.
I mean, we've all felt it, right? Whether you're using ChatGPT or some kind of coding assistant, these tools can feel, well, magical. They write, they translate, they reason in ways that were honestly just science fiction a few years ago. And their impact has been so profound because they've totally redrawn the map of what's possible with AI.
So how does it really work? How do you go from a completely blank slate to a machine that can break down quantum physics or write a poem? What's the actual engineering plan? That's the blueprint we're going to uncover today. We're moving past the magic and getting right into the mechanics.
Okay, so every great vehicle needs an engine. And for modern AI, that engine is something called the transformer. It is the absolute core, the powerhouse behind pretty much every single large language model you use.
See, before 2017, older models had to read text sequentially, one word after another, kind of like we read a book. The transformer was a total revolution because it could look at all the words in a sentence at the exact same time, in parallel. This was a massive leap in speed, and it unlocked a scale that nobody could have imagined before.
But you might be wondering, how does it understand context if it's looking at everything at once? Well, the secret sauce is something called the attention mechanism. Think about how your own brain is processing my words right now. You're naturally focusing on the key ideas, not the little filler words. Attention lets the AI do that exact same thing.
So conceptually, it's pretty straightforward. The model takes in a chunk of text, and for every single word, the attention mechanism calculates how relevant it is to every other word in that text. This builds this really rich contextual map of the whole sentence. That ability to focus, to pay attention, is what makes this transformer engine so incredibly powerful.
Now, an engine is totally useless without fuel. And for a large language model, that fuel is data. And I mean a truly mind-boggling amount of it.
30 trillion. And get this, that isn't the total data for all the models out there. No, that's the number of tokens from just one single open-source training data set. And to try and put that insane scale into perspective, it's basically the same as reading the entire English Wikipedia 5,400 times over. This vast ocean of text, books, articles, websites, code, this is where the model learns everything it knows. It's where it picks up grammar, facts, and even its ability to reason. And this learning process happens in two main stages. First up is pre-training. This is where the model just predicts the next word, over and over and over again, across trillions of examples. This is what teaches it the patterns of language. But it just creates a text completion machine. The real key is stage 2, fine-tuning. This is where it's trained on smaller, high-quality, human-curated examples to become a helpful assistant that can actually answer your questions and follow instructions.
So our engine is built, it's all fueled up. The next piece of our blueprint is the steering wheel. How do we actually guide this incredibly powerful system to get the specific results we want?
Okay, just look at this comparison. If you ask a base, pre-trained model how to make pizza, it might just continue your thought with another question. It's just a simple text completion machine. But an instruction-tuned model gets what you're asking. It doesn't just complete the sentence, it actually answers the question. That right there is the difference between a raw engine and a finished car.
But here's the thing. Fine-tuning an entire model with, say, 70 billion parameters is unbelievably expensive. And that's where really clever techniques like LoRa come into play. Instead of retraining the whole engine, LoRa basically freezes it and just adds a few tiny, trainable parts on top. This makes it so much cheaper and faster to specialize a model for a specific task, like analyzing legal documents or adopting a brand's voice. It's making custom AI accessible to way more people.
All right, so we have an engine, we have fuel, and we have controls. But right now, that's just a go-kart. To build a truly smart and reliable application, we need to build a proper vehicle around it, a system that makes our model even more useful in the real world. Think of it this way. A model's training data is kind of like its long-term memory. The problem? Well, that memory can be outdated or just plain incomplete. So what if, instead of asking it to remember something from a closed-book exam, we could just give it the textbook right before the test?
Well, that is the core idea behind a technique called retrieval augmented generation, or RAG for short. The system connects the LLM to an external, live database. Think your company's internal documents, the latest news, product manuals.
This is an absolute game changer because it grounds the model's answers in verifiable, up-to-date facts, and that dramatically cuts down the risk of making stuff up.
So here's how that full blueprint works in practice. Let's say you ask about this quarter's sales figures. Instead of just relying on its old training data, a RAG system first searches the company's live sales database. It pulls the relevant report, sticks that info into your prompt behind the scenes, and then asks the LLM to generate an answer. The result? You get a perfect, fact-based response. This is the architecture behind most of the really reliable AI applications out there today.
So there you have it. That's the journey, from the core engine all the way to a fully functional AI application. Let's look at the complete blueprint we've just put together.
Our blueprint really has 4 key parts. We've got the engine, which is that amazing transformer with its attention mechanism. We've got the fuel, those trillions of tokens of data it learns from. The controls are how we steer it with fine-tuning and prompting. And finally, the application is that RAG framework that grounds it in real-world, current information.
And you know, at the end of the day, what feels like AI magic is really just the result of brilliant, layered engineering. And yeah, it's incredibly complex, but it's not unknowable. It's built on a clear blueprint, a blueprint that was designed and built by people. Which leaves us with one last thought. We have the blueprint for one of the most powerful technologies ever created, and that blueprint is getting better every single day. So the real question for all of us is, what problems should we solve with it next?